So the top K algorithms that we have so far, we talked about using sorting, which runs in time n log n, because you sort the whole list and then you can get any top K that you want for any K. So it doesn't depend on K. The selection and insertion approaches both ran in big theta of n times K, essentially because we're repeating for each of the elements that we want to get out, we're repeating something like n work. But now we have a third, well, I guess now we have a fourth approach, which uses this partitioning idea recursively to get an expected running time, a big theta of n, which is better in the worst case than sorting, and better than selection and insertion for any K other than a constant, and for a constant they come out the same. So this is actually a pretty remarkable algorithm. I actually haven't found much use for it in practice, but it's sort of, I guess it's sort of nice to know that it's there. The algorithm that I have found very useful in practice is to use the selection and insertion approach, but to use a different data structure than just a list to do the insertions into, and that's a heap. And what the heap is going to give us is a running time that is n times the logarithm of K, which is going to be better than sorting except for when it ties it if K is order n. And it's definitely going to beat the selection and insertion approach. It doesn't do as well at partition at this particular problem of finding the top K, but it actually is pretty useful for a bunch of other things as well. So let's dive into the whole universe of heaps now.